For this case, side A, okay, SSA. So we know two sides and one angle. And this angle is not between two sides. Then we may have three situations. One is there is no such triangle does not exist. Two, only one triangle satisfies the thing we already know. And three, the third situation is there are two distinct triangles satisfy these three SSA. Okay, why this would happen? I use another color to tell you the reason. Okay, if we have a triangle, okay, I use this is the box. Okay, if we know a triangle, if we know this angle A, okay, and we know the side A, then if this side A is less than this height h of this triangle, this A is acute angle. If A is less than h, then we notice that there is no triangle, no such triangle. Okay? If A is equal to h, then you will see that there is only one triangle. If A is greater than h, this is h, this is A, right? So this is h. If A is greater than h, so A could be here or here, right? So we may have two triangles, two distinct triangles. Okay, so this is for the case A is acute angle. If A is a obtuse angle, okay, and if this is A, and this is side B, for example, this is A, and this is side A, if A is less than B, because we know a obtuse angle is the largest angle in a triangle, right? So the side A should be greater than the other two sides. The side A should be greater than the other two sides, right? So if A is less than one side, then there is no triangle. Okay, if A is greater than, if A is greater than one side, then there is only one triangle, right? Okay, so these are the reasons we may have these three situations. But when we solve the problem, we don't need to check these rules. We just need to know here. It just tells you the reason why we have these three situations. Okay. So when we solve this kind of problem, we still need to draw a little chart, right? So let's look at examples. This is one example for the SSA. For example, we know this is, for example, this is side A, side B, as angle A, angle B, and the angle C. And we know angle A is 40 degrees. And we know two sides, B is equal to 2 and A equal to 3. So this angle is not between side A and side B, right? So this is the SSA. Right, this is the SSA. So we still need to draw a little chart. Right, B equals 2, A equals 3. And side angle A equal to 40 degree, and the angle B we don't know. And the angle C is the thing we are looking for. Okay. So here is one thing. So since we know this opposite side and the opposite angles, we can use the law of sine to calculate the angle B, right? If we know angle B, then we can calculate angle C, right? Okay. So now let's look at this is the, so we use law of sine. So the sine A over side A is equal to sine B over B, right? So we know B, side B. So we can calculate, it tells you that sine B is equal to B times sine A over side A. We plug in the number, so it would be 2 times sine 40 degree over 3. So in other words, if you calculate this one, okay, and there is, if we want to calculate angle B, right, we need to have, so this is a positive number, right? So sine B equal to a positive number. So B could be, since B is between 0 and 180, so we actually have two angles, right? One is acute angle, the other one is its supplement or another obtuse angle, right? So we may have B is equal to, we may try to calculate the sine inverse of this number, which is 2 sine 40 degree over 3, right? This will give you the acute angle because sine inverse is from negative pi over 2 to pi over 2, right? Since this is a positive number, this is positive, so it must be an angle between 0 and pi over 2, less than 90 degree, greater than 0, right? So if you use a calculator, it will tell you which is 25.4 degree. Okay, so but this is just one angle, right? Another angle is B or B equal to what? B equal to its supplement angle, right? Because this is 25, right? This will have the sine value. This is 25.4 degree, and we also have another angle. This terminal side is here. This the reference angle is 25.4 degree, right? So, but these two angles, this angle and this angle should have the same sine values, right? So this is the supplement angle. So how to get this angle? It's equal to 180 minus 25.4 degree. So if you do the calculation, it would be 154.6 degree. So which one, right? We may have two or one triangles. We don't know, but you look at this one. If we write, if B equals 154.6 degree, then you notice that if you add angle A and the angle B up, you will see it's greater than 180 degree, right? If B equals 154 degree, then add 40, it is 194.6 degree, which is greater than 180 degree, right? We know the sum of three angles should be equal to 180 degree. It cannot be greater than 180, so that is not the case. It's impossible. The reason is if you add the angle A, it will greater than 180. So we only have one choice. So this one is the one we're looking for. Okay. So you cannot just find the solutions and fill in the director. You need to look at which one, right? Or both are correct, or just one is correct, right? Since we know angle A and angle B, so then we can calculate angle C, right? Angle C is equal to 180 degree minus 40 degree minus 25.4 degree, which is equal to 114.6 degree. Then we can use side A and angle A and side C and angle C to find the side C, right? So sine A over side A is equal to sine C over side C. So C is equal to A times sine C over sine A. If you plug it in, okay, if you plug in everything, so A is equal to what? A is equal to 3, so it's 3 times sine 114.6 degree over sine A. Sine A is sine 40 degree. If you do your calculation, it would be 4.24. Okay, 4.24. So this is 4.24. 4.24. We have no problem with that. So in other words, for this case, we only have one triangle, right? So now let's look at another. We still have ABC, okay? And this time, if this is C, ABC, okay? This time we know side A is equal to 2, side C equal to 1, and we know the angle C. Angle C is 60 degree. Okay, so we want to know if we can solve this oblique triangle, so we still need to draw a little chart. A is equal to 2, B is the thing we don't know, and C is equal to 1, right? And the angle A we don't know, angle B we don't know, and angle C is equal to 60 degree. So we know this pair, so we can use this law of sine to calculate the angle A, right? So we notice that, so we use the law of sine. Sine C over C is equal to sine A over A, right? We solve for angle A. So it tells you that sine A is equal to what? Equal to A times sine C over C. If you plug in the numbers, A is equal to what? Equal to 2, and C equal to 1, and this is sine 60 degree. Sine 60 degree equals 2 times square root 3 over 2. So this is square root 3. So sine value equals square root 3. Okay, so this is a question because this is square root 3 is greater than 1. We know the sine value is always between -1 and 1. But this, the law of sine tells you that the sine A is what? Is greater than 1. It's equal to square root 3, greater than 1. So that means it's impossible, right? Impossible to have a triangle which is sine A is greater than 1. So there is no triangle. Okay, the reason is if you calculate this h, right, this is the h, you will notice that this c is less than this h, right? This is the reason. the reason behind the problem, right? But we actually don't need to know that. We just do the calculation, you will see, okay, we cannot continue. So there's no triangle. So now let's look at another example for side A. So this is the, if we know, okay, so this is the angle A, angle B, and the angle C, and the side A, side B, and side C. This is side A, side B, and side C. Okay, we know that A is equal to 6. B we don't know. C equals 10. And angle A, which is equal to 35 degrees. Right? So we know two sides and the angle, which this angle is not between these two sides. And this angle B is the thing we are looking for, and angle C is the things we are looking for. Okay. So since we have this pair and this side C, so we can use the law of sine. So sine C over C is equal to sine A over A, right? So sine C is equal to 10, C, so sorry, I should write one more step, C times sine A divided by the side A, so which is equal to 10 times sine 35 degrees over 6. Okay, so if you have actually this is a positive number, right? This sine 35 degrees is positive, so this is positive greater than 0, so that means you have two choices of C, right? Between 0 and pi, 180 degrees. So one angle is C, one is equal to sine inverse of this number. This one will give you an angle less than 90 degrees. Okay, but greater than 0 because this is a positive number. So it will tell you that this angle would be approximated by 72.9 degrees. Another choice of C, which is the supplementary angle of the C1, so which is the 180 degree minus the C1, right? The reason is, again, this is the reason. We have these two angles, right? This angle and this angle. These two angles have the same sine values. Because one angle is the supplement angle of the other one, right? So this one is equal to 180 degree minus 72.9. So this is equal to 107.1 degree. So like we did before, we needed to look at if we plug in the angle C, if there is a greater than 180, right? If we add them up, right? Okay, so this is the, if we have 72.9 degrees, so we add 35. Okay, of course, no problem, less than 180. So we can always find the angle B, right? And if we have 107.1 degrees, so we add 35 degrees, so it's still less than 180. So we still can find the angle B. So that means you have two triangles. So both are all the correct angles it could be. Okay, so we have two triangle ones. I just, for your convenience, we just draw the triangle one separately, which is A equals 6, B is the thing we're looking for, and C equals 10, and the angle A is equal to 35 degrees, and the angle B, which let's look at this. Okay, angle B we don't know, and angle C, which is equal to, we choose the first one first. 72.9 degree. Okay, so let's look at this angle. So since we know the angle C already, so angle B is 180 degree minus 35 degree minus 72.9 degree, which is equal to 72.1 degree. So we know this pair, this is the pair we're already given, right? Not the pair where we calculate. So there's no any approximation error. Then we know this one and this one. We needed to calculate this one, right? Okay, so we use the sine, law of sine. So sine A over A is equal to sine B over B. So it tells you that B is equal to A times sine B over sine A. If you plug in the numbers, then you will see it's equal to B side B is, let's calculate it. So this A is equal to what? A equal to 6 times sine B. Sine B is 72.1 degree divided by sine 35 degree. Right? So it's 6 times sine 72.1 degree divided by sine 35 degree, which is equal to, so this tells you it's equal to 9.95 units. So this is 9.95. Okay. I should have used red. 9.95. So this is the one triangle, right? So actually everything is acute angles. These three angles are acute angles. So this would be the case where this A is here. So this would be the case. Sorry. This would be this case. Okay. This would be this case, this triangle, right? All the angles are acute angles. So now let's look at the triangle 2. Triangle 2, which is A is given, B is 6, B is the thing we're looking for, C is 10, and angle A is 35 degree, and the angle B we don't know, and the angle C we calculate, which is, this time we choose this one, right? 107.1 degree. So now we can calculate this one. This is just the angle B, which, because the sum of three angles should be equal to 180, so it's 180 degree minus 35 degree minus 107.1 degree. So it's equal to 37.9 degree. Okay, then we have everything. So we have this pair, and we can use the law of sine to calculate side B. So sine A over side A equals sine B over side B. So this tells you that B is equal to A times sine B over sine A. So A is equal to 6 times sine B. B is, we calculate 37.9 degree, right? 37.9 degree over the sine A. A is equal to 35 degree, right? 35 degree. Okay, so you use a calculator. You will see this one is 6 times sine 7.9 divided by sine 35. So which is about 6.43. Right. So here is 6.43. 6.43. So you can see this is actually, we have a one angle which is a obtuse angle. So this is this case, right? This case. This obtuse angle. So actually for this problem, we have two cases, right? So the remark for this problem. So this problem we may have two cases, right? One case is here, and the other case is here, right? So one is three angles are acute angles, and one is obtuse triangle. Okay, so this is also we talk about all the situation for the SSA case. So this case you should be careful, which is ambiguous case. Okay, we may have non-triangle, we may have one triangle, we may have two distinct triangles. So now let's look at one application, which is the theorem. If we know two sides and the angle between these two sides, in other words, which is SAS, right? Then we can calculate the area of this. Then the area of this triangle we can calculate is, so let's look at, we use some, if we know side A, angle A, and we know this is the, for example, this is B, side B, and side C, right? If we know this one, then this area is equal to area is equal to 1/2 times B times C times sine A. Okay, so you can see if A is a right angle, so sine A is equal to what? Equal to 1, right? So it's actually, if this is A is a right angle, so it's the height, B is the height, and C is the base, which is just 1/2 B times C, which is consistent with the formula for the area for a right triangle, right? So, but now if A is not right triangle, it could be you need to multiply by sine A. If this is the case, okay, so actually we just need to know if this is the B, if we know the side, the angle B, okay, and we know the side C and the side A, right? So this area is equal to actually 1/2 A times C times sine B, right? If we know this one, if we know the sine, the angle C, and we know this A and this is B side B, okay, then the area is equal to 1/2 A times B times sine C. Okay, so actually these three cases are exact same, just used in different letters, right? So in other words, the area of the triangle can be written as 1/2 B times C times sine A, or can be written as 1/2 times A times C times sine B, and O equal to 1/2 times AB times sine C, right? Okay, so now let's look at this one, right? So if we have a triangle, and this is a 102 degree, and this side is 52 units, and this side is 90 units. Okay, what is the area? So we can calculate the area is equal to 1/2 times these two sides, 52, 90, times sine of this angle, 102 degree, right? If you calculate, which is 1/2 times 52 times 90 times sine 102 degree, so which is, okay, so this is 2288.87 square unit.